In this tutorial we're going to focus on water and what makes it such an important molecule for living creatures. In the next few slides there's some information that it might be worth pausing the tutorial just to read through, but there are just a few key points that I would like to highlight. Water is quite unique, and when we often look for life on other planets or signs of life, one of the first things we look for is the presence of water, since it seems to be such a fundamental molecule to allowing living things to exist. As you would well know, water's basic chemistry is that it exists in three forms, or it can exist in three forms, as a solid, in the form of ice, liquid water, and gaseous water, as water vapour. It covers about 75% of the Earth, but interestingly for our interests, it makes up about 78% of the human body. The thing that makes water unique is its molecular structure. It's a polar covalent molecule, which means, and we'll look at this in a little bit more depth in a minute, but essentially a polar molecule is one that has electric charges on it. In this case, the water molecule has both positive and negative charges at the opposite ends of the molecule. The fact that it's a covalent molecule means that it shares its electrons between the different atoms in the molecule. We'll have a look at a picture of this in just a moment. It's also a slightly bent molecule, so we know that oxygen is bound to the two hydrogens to make up H2O. The oxygen's negative and the hydrogens are positive, and it's this polarity, its covalence, and its shape that give it the properties that allow the creation and support of life on Earth. So polarity, we're going to look at hydrogen bonding, what we mean by cohesion, and surface tension. So let's have a look at polarity first of all. As this sentence says quite clearly, polarity simply means that the molecule is both positively and negatively charged. It has a positively and negatively charged end. This polarity can be seen in this diagram to the right. And we can see oxygen, which is the larger of the two kinds of atoms found in water. So oxygen has a negative charge, and the two hydrogen atoms, which are both much smaller than oxygen, have positive charges. So this is the polarity. So we have a negative and we have a positive end to the molecule. So it's this polarity of water that also helps it to dissolve other polar or charged molecules such as sugars and various ionic compounds such as salts and other such inorganic compounds. So remember that for biological reactions to occur, they usually have to occur, well not usually, they always have to occur in water. So to be able to dissolve various molecules in water is very important for life. So water is able to dissolve many common substances because of this property, and it's often referred to as the universal solvent. So things or molecules that can't be dissolved in water, such as oils, are generally described as lipid or fat soluble and are non-polar. So this is one of the key properties of water that you need to be familiar with. Another one is what's referred to as hydrogen bonding. And this is the ability for water to bond to other water molecules and to other molecules that have a polarity to them, because negatives are attracted to positives and vice versa. And so this attraction that can occur between the positives and negatives can form a very weak bond referred to as a hydrogen bond. So when water molecules line up with each other, this weak bond is established between a negatively charged oxygen atom of one water molecule and the positively charged hydrogen atom of another water molecule. This weak bond that's formed between hydrogen atoms and the neighbouring atoms is referred to as a hydrogen bond. And it's very common between the biomolecules of living things. One of the classic examples is that hydrogen bonds form between the various bases of DNA, the cytosine, guanine, adenine and thymine, and uracil of RNA. So these bases or complementary base pairing occurs because of hydrogen bonding. So it's a weak bond, easily formed and easily broken. These hydrogen bonds also give water two other properties that are important to life. That's the property of cohesion and surface tension. Let's have a quick look at these. So cohesion is when like molecules, that's molecules that are the same, can bond together. And since water is a polar molecule, it can bond with other water molecules. So they cohere, that is, they bond together. So this extensive hydrogen bonding in water means that the water molecules will tend to stick together in a regular pattern, and it's this that's called cohesion. And you can see this obviously when you pour water out of a cup or whatever. Water doesn't just splay off into tiny little droplets here and there. It exists as a body of water. It's held together. The water molecules hold themselves together. So this also relates to another particular important property of water for life, and that is the ability of cohesion to hold water together also provides the property of surface tension. By surface tension, we mean that the water molecules that line the surface of a body of water obviously are still held together by cohesion. We can see this here. And this forms a kind of almost a bonded net, if you like, of atoms and molecules across the top or surface of the water. This surface tension allows creatures like water spiders to be able to walk on the water, and as long as you're not too heavy, you can walk across that water surface because the strength of the bonding between the water molecules is greater than the weight of the object on top. Adhesion is similar to cohesion, except this is where unlike molecules are bonded or held together. This might be an example of where water molecules on the sides of glass containers can bond to glass or to another kind of substance like clay or so on. So you get this kind of bonding between unlike substances. This is adhesion. Cohesion, remember, is the bonding between like substances. So adhesion, you can see, helps to draw water up thin tubes like thin glass pipettes, because the bonding of the water to the glass creates a tension which pulls the water up through the glass tube in a kind of a capillary action. So these key properties of water allow all of life on planet Earth to function and to exist effectively. And without water, life simply wouldn't be able to exist as we know it on planet Earth. So let's just remind ourselves again quickly. Polarity, that ability of the the water molecule to have a negative and a positive end to it, so that positives and negatives can then bond with each other between molecules, and it also allows a whole range of solutes to dissolve in water. Hydrogen bonding is the bonding between the positive hydrogen and the negative oxygen of another molecule, which can create bonds that hold molecules together. And then cohesion is the ability of water to hold itself together because of the polar bonds between them, the hydrogen bonds between them. And then surface tension is the tension created by cohesion across the top of a water surface, which kind of acts as a kind of a net across the top of that water.